Hello everybody, again welcome back to Ram circuit class. Okay, today we are going to deal with topic called terminal potential of any given cell, right? So what is terminal potential? And before introducing that idea, we must understand what the electromagnetic force of a cell is all about. So let's understand what is electromagnetic force first. It's a very simple and basic definition we are going to start with. Okay, imagine we have a cell. This is a cell made up of two electrodes dipped in it, as the construction is known to everybody. So this is a kind of electrolyte. Say this is positive terminal, this is negative terminal, whatever. We are not going into deep of the structure formation and transformation, origin of cathode, origin of anode, how potential becomes positive, how becomes negative, nothing to do with that. So we have to understand that suppose this is a cell and I get a measuring device called voltmeter, and voltmeter does the job of what? Measuring the potential between any 2 points in any circuit, or between any two terminals of any circuit. Okay, so these are two terminals, that is one positive, one negative. You connect what? A voltmeter. Mind this cell is not providing any sort of current. And one more thing, this voltmeter has a very high resistance. So if the resistance is enormously high, and this cell generally, if produce suppose 2 volt, then this 2 volt is not enough to produce a current through this high resistance, and its resistance is in the order of 10 to the power 4 ohms. Okay, so this 2 volt battery is unable to produce a current in this circuit. If the current is produced, then it will be obviously very small. So for that particular segment we do not count that. Okay, so for now the current is not in the circuit, but this device voltmeter shows a little bit of deflection, and that deflection is known as the potential between the negative terminal of the battery and the positive terminal of the battery. Suppose the deflection given by this voltmeter when connected in this way, there is no extra resistance, mind that, then the showing or the reading of the voltmeter is if 2 volt, as I told, say this is of 2 volt cell, then this 2 volt as shown by this voltmeter in this particular condition, mind this, there is no external or another device connected except what? A voltmeter. So this 2 volt is known as EMF of the cell. Okay, this 2 volt is known as the EMF of the cell. So in case of bookish language, we must say when there is no current being drawn from the battery, then the potential difference between the positive and negative terminal is known as the EMF of the cell. Or in other words, when we complete a circuit, this is a cell, this is external resistance R, and we discussed in the last topic on the last lecture that every cell has its own internal resistance denoted by R, and that can be connected either this side or that side, does not matter, but it will be connected, and this whole is combining what? A cell. So if these are the points A and B out of the cell, mind that, then a charge particle, say of 1 coulomb, how much? 1 coulomb. A charge particle of 1 coulomb, if it is started moving from this point, that is positive terminal of the cell, and it completes one round through the external resistance, through the internal resistance, and then finally comes to the positive end again. It has started from the positive end and finally coming back to where? the same point, then the total work done, in moving a charge of 1 coulomb from the same point, this point may be here. Suppose my starting point is here and I take the charged particle at rest over here, and when the battery is applied, the battery does some job. Now, who is moving this charge? Obviously the battery. The battery is called what? The driving force, right? The battery is the driving force. The driving force simply drives the 1 coulomb of charge from this point to hold the circuit and then coming again to that particle. Means, remember, in case of EMF, you have to start your starting point and the end point should be same. Either it is positive terminal, either it is negative terminal, or whichever, does not matter. So, amount of work done in moving a complete round of 1 coulomb of charge is known as what? EMF, and denoted by this. So, this is called EMF of a cell. That is, and this is known as, or this is the maximum potential difference between the terminals of the cell, between the terminals of the cell. Remember, when no current is drawn, when current is not drawn means I should be 0. As I told earlier, when a voltmeter is connected, it has high resistance of this order or maybe more than that, then this is a small cell cannot produce any sort of current. So, if current is not being drawn, the total amount of work done in moving a unit charge, what? How much? Unit charge from any point, again having a complete round to that particular point. So, that is defined as the total work done, and that work done is known as the EMF of a cell. Actually, this formula comes from the relation, that is EMF is a kind of what? Voltage. You must be known as EMF, electromotive force. Please don't get confused that this is a force. This is not a force, this is a kind of potential. This is only a potential, but the name is simply EMF. So, we are not to discuss here what is the history behind its name. So, EMF is exactly what? A kind of potential, and by definition we know that the work done, suppose this is point A, I am starting from A to this again to A, that is A, R means this, I started from here, go to R, then coming back to B, again come to point A. Okay, potential is defined as total work done in upon how much? The charge, and charge is 1 coulomb. So, we must write W, this is A R B A over 1. So, that's your EMF, and this is equals to simply what? Work done. So, that simply completes the idea of EMF of a cell. Okay, that's clear. Now, we shall discuss the current topic, that is our today's job, to establish a relation between the terminal potential and its EMF of a cell. Okay, so we have got the circuit for what we have to do the job today, and that is the terminal potential. Now, these are the terminals of a cell, and this is completing what? This cell, because this is a small r, internal resistance of the cell, and these are the two ends, and the ends of this external resistance are connected to the battery. Got? Now, what will be the total work done in moving a 1 coulomb of charge from this to that particular job? That will be the EMF of the cell. So, EMF of the cell is the total amount of work done in moving 1 coulomb of charge from point A to B, or B, and then B to A again. Okay, now let's do that. Suppose this cell is sending a current I in the circuit. Now EMF is equal to so how much will be the work done? How much will be the work done in moving, that is work done in moving a unit charge from A to B via external resistance plus the work done in moving from B to A. B to A, or I must write here for a specification BRA. BRA means through the cell. The charge is being moved from B to A but through the cell, and this is what the first term is for external path, right? But according to Ohm's law, EMF is equal to V, that is A to B, plus B to A multiplied by charge plus V dash BRA multiplied by charge, and the charge is how much? 1 coulomb. So EMF is equal to VAB plus V dash BRA, and by Ohm's law. What is Ohm's law? Now mind this, the current I is being moving through the resistance R. So this is producing a potential, that is I into R. So the first term VAB becomes I multiplied by the external resistance. Simple, no question should be there. That is EMF is equal to I into R plus the same current. You know that in series combination the same current flows through each and every element. So the same current passing through the through the region inside the cell. So this is equals to the I, and what is the resistance inside it? That is R, and this IR is called the potential between. Now one more thing I must express here, that is connecting wires. Connecting wires never drop any sort of potential, rather they carry the potential from one to other point. Mind it, this is point A. Suppose the potential at this point is 10 volt, and this is a single connecting wire. If this is point C and that is point D, then point A is at 10 volt, then by definition this is a connecting wire, so point C will be at 10 volt. Now if B point is at -1 volt, then D point must be at -1 volt. So the potential difference across the ends of the resistance, that is C and D, is given by what? VC minus VD, that is equal to 10 volt minus and -1 equals to 11 volt. This is how we have to understand the things. So V is equals to IR, and this is again I am writing V plus I into R, and that is your EMF. This is one relation, or further we write, so this V is what? The terminal potential which is just have done, that is 11 volt, or potential across the ends of the two ends of the conductor. Okay, that is potential difference between this end and this end. Now one more thing, current always flows from high potential to low potential. So this is say potential at C, that is Vc, and this is at potential, that is say V of D. The current is moving in this direction, that is high potential to low potential, and their difference is known as V, that is V equals to I into R, as I have written here, and that is equal to Vc minus Vd. Okay, so V is equal to EMF minus I into R, that is known as what? Terminal potential of the cell. Now once in one case I am saying V is the potential across the resistance, and I am relating this idea to that particular topic, that is terminal potential of a cell. Now say the things are same, little more literal difference, that is point C and point A are same potential, and point D and point B are at same potential. So whatever is the potential across the ends of the conductor or ends of the resistance when the current is being drawn, same will be the potential across the ends of the cell, that is A and B. Okay, the same will be the potential across A and B, and that is known as EMF of terminal potential of the cell. So for a better understandability, we can write that is VCD. CD means potential difference across C and D. A potential difference between the points of the resistor is equal to V between A and B. That is potential difference between A and B, because both the points are same. C is connected to A and D is connected to B, and that is equal to EMF of the cell minus IR. And what this IR is? That is simply the potential drop inside the cell due to its internal resistance. As we discussed in the last video, what is internal resistance? The reason of its rise we have done. So this is in general known as what? Terminal potential of a cell. That's it. Okay, so this is the relation between terminal potential V and EMF of a cell and the internal resistance of the cell. Okay.